Assalamualaikum warahmatullahi wabarakatuh. So our group will present about Green's theorem. So there are two questions of Green's theorem. So this is our group members. So my name is Nur Alia Iwani binti Abdul Wahab. So the next is Nur Alia Farhana binti Muhammad Yusof, and our next group member is Nurul Fazlin binti Aziz, and the last one is Shafika Izlin binti Saparwan.
George Green, a British mathematical physicist, is the eponym of the Green theorem. In 1828, he published an essay that talking about the use of mathematical analysis in the theories of electricity and magnetism. But this idea was not acceptable, and this idea became logic and official by the Lord Kelvin that enhanced the Green's theorem become the Stokes theorem. Green theorem helped in establish a relationship between a double integral over a region in the plane and a line integral around the boundary region. It states that let D become a simple region, which means that a region must be connected by the plane, and let C be its positively oriented boundary curve. This theorem also states that the formula is double integral of P dx plus Q dy, and the dA, which means the area, can be x and y, or in circular we call it as r dr d theta. So for question 1, say is evaluate integration of y square minus x dx minus 4y dy using Green's theorem where C is boundary of region D as shown in figure 1. First of all, we need to identify the P and Q. So P is equal to y square minus x and Q is equal to negative 4y. We differentiate the Py, we get 2y, and the differentiate of Qx, we get 0. Then we put the value in Green's theorem formula, which is double integral Qx, which is 0, and minus with Py, which is 2y, then dA. Now, the problem is where the region, in what boundary that we need to find. So, we need to identify the dA is what. So, based on this question, we use dA equal to dy dx, and we need to find the limit of y. We use the gradient method as the region is straight line. So from point 24 to 06, the gradient formula is y minus 4 over x minus 2 and equate with 6 minus 4 over 0 minus 2, then we get y is equal to negative x plus 6. The second point is from 06 to negative 2, 4. The calculation work is same as the first one, and we get y equal to x plus 6. Then we substitute the value into the formula and need to integrate the insider term first, which is dy. So then we integrate terms of dx. Then making the usual integration, we get the answer is negative 1328 over 15, and we know area cannot be negative. So the final answer, we change it into the decimal point, which is 88.53.
For the maple solution for question 1, here are the commands. First, we need to write restart. Then we write with vector calculus. Then we need to put the function from the question. After that, we need to identify which is P and which is Q. After we identify which is P and Q, we need to do partial differential of P and Q, which is we need to find Py and Qx. And after we get the Py and Qx, we will get the S. So how to find the S is Qx minus Py. Settle for that one. We move to the line segment. The line segment for the point 1 is 2 to 4 and point 2 is 0 to 6. Then we put y minus 4 over x minus 2 equal to 6 minus 4 over 0 minus 2. After we cross multiply, we will get y equal to x negative x plus 6. And for the line segment number 2, for the point 3 is 0, 6, and point 4, negative 2 to 4. We do the same, which is y minus 4 over x plus 2 equal to 6 minus 4 over 0 plus 2. Then we will get y equal to x plus 6. After that, we need to plot. So the command is with plots. Then we need to plot 3D. So the command is plot 3D y square minus x minus 4y x equal to negative 2 to 2, y equal to 0 to 4. Then we will get the output. Alright, this is the output when we use the command, and we will get the answer and the plotting.
Next, we go to the next question, which is use Green's theorem to evaluate contour integral 8x to the power of 4 dx plus x dy, where C is the boundary of the shaded region, given in the figure 2 oriented counterclockwise. So, this is the solution of manual calculation for question 2. So, first thing first, the formula is contour integral f dr equal to integral p xy dx plus q xy dy equal to double integral partial derivative q over partial derivative x minus partial derivative p over partial derivative y dA. So this is the equation from the question. And then we let the p equal to 8x to the power of 4 and the q is 0. So when we differentiate the p, we will get 0, and when we differentiate the q, we will get 1. And then we make qx minus py so that we will get 1 minus 0. Next, this is the formula for Green's theorem, which is contour integral f dr equal to double integral partial derivative q over partial derivative x minus partial derivative p over partial derivative y dA. Then we take the equation from the question and we will make it equal to double integral partial derivative q over partial derivative x minus partial derivative p over partial derivative y dA. Then from limit 0 to 4 and from limit negative 1 over 2x squared plus 2x to 4 minus x minus 2 squared, 1 minus 0 dy dx. 1 minus 0 we take from the qx minus py. Then after we write this equation, then we integrate the equation with respect to y, and then we will get y. Then we substitute the y with the limit of the equation. Next, after we simplify the equation, then we integrate the equation with respect to x. So after we get the answer, we will substitute the equation with the limit of 0 to 4. Then we will get the last answer is 5.333. Mapper solution of question 2. We restart the mapper, then use command with vector calculus, and then the output will appear as shown. We will define f equal to xy vector field 8x power of 4, comma x. Next, we define p equal to 8x power of 4 and define q equal to x. To find s, we use command s equal to differentiate q minus differentiate p, and we get s equal to 1. After that, we solve the Green's theorem, and the answer is 16 over 3. Next, we need to plot the graph. First, we use the command with plots. Then, we use plot 3D 8x power of 4 plus x, comma, x equal to negative 2 until 2 and y equal to 0 until 4. The graph will appear as shown in the table. That's all from our group. Thank you.